I see what you done there, Lee. You said highly educated. That's really clever. All right, so guys, we're going to be talking about the models of atoms today, right? A model is basically a diagram or a picture, all right, of how an atom supposedly looks, right? So if you have to see an atom through a microscope, it's going to have this kind of a structure. So in the middle, we have protons, which carry a positive charge. And then we also have neutrons, which carry a negative charge. And lastly, on the outer orbitals or rings, we have electrons, and electrons carry a negative charge. What keeps electrons spinning at incredible speeds around the nucleus of an atom is the negative and positive attraction, all right? So the only way that electrons are not flowing out of orbit is because of that strong negative and positive attraction. Okay, so let's look at, I have 3 atoms here today, right? So I just picked them from the periodic table. Tell me, is oxygen a metal or non-metal? Tell me in the chat. Non-metal, excellent. What about beryllium? Beryllium is a metal, good Amma. Yes, very nice, right? And hydrogen, we know it's also a gas. What happens when we take hydrogen and we bond it with oxygen? What compound do we get?
Carbon dioxide.
Guess again. We're taking hydrogen and we're joining it with oxygen. We're getting water. Good. Right. So guys, right, so how do we know how many protons and how many electrons we need to draw around in our model? If we look at the elements from the periodic table, we'll see that the smaller number tells us how many protons and how many electrons are within the atom. So I see within oxygen there's 8, right? So there's supposed to be 8 protons and 8 electrons. So I'm just going to draw that quickly here. Just need 2 more. I'm good. Yeah. Okay, it's really squashed out, my bad. Okay, and if there's 8 protons, then I need 8 electrons as well. There we go. Right. How do I know how many neutrons to put? Neutrons are these neutral guys over here. Well, if I look at the smaller number on the element, it will tell me the number of neutrons plus the number of protons, right? It sounds complicated now, but I promise you it isn't. So if you look at this number here, it says 15.9994, all right? I want you guys to always ignore that decimal and convert it. Convert it to the next whole number. So if 15.99 is the number there, how would you convert it to the next whole number? And you all should know this, even if you're doing maths lit. Good, 16. Yeah, there we go, right? So that means that altogether there are 16 protons and 16 neutrons, right? So if there are 8 protons, then how many neutrons are there? There's 8 protons, how many neutrons are there? Yes, Christopher said 8. Excellent. Okay, so I'm just going to repeat myself. The smaller number tells me how many protons and electrons there are in an atom. The bigger number, which we need to round off, tells me how many neutrons and protons there are all together. All right. From iPad to everyone. Man, my iPad's going to die and my charger is broken. Oh my word, story of my life. Okay, so I'm going to record this lesson, put it on YouTube, and then just remind me after the lesson and I'll send you the link. Okay. Okay. All All right, so guys, in the middle, there need to be 8 neutrons, right? And then 8 protons, because 8 plus 8 will give me 16. Let's look at beryllium over here. Just going to zoom in real close to beryllium. So beryllium has an atomic number. We call the smaller number atomic number. It has an atomic number of 4, all right? And if we look at the bottom, what is that bottom number called? The bigger number. Tell me in the chat. Atomic mass. Excellent, Kian. Well done, right? So how would I round off 9,01 to the nearest whole number? Good, it will be 9, right? Because if we look at the next number after the comma, it's less than 5, all right? Because it's less than 5, we stay on the original number. Now, guys, I know what you must be thinking. Oh, no, we're doing maths in science. How can this be? I promise you, we're not going to go further than rounding off and plus and minus. That's it. Okay, then, so we look at how to draw the beryllium atom. So in the middle, because our atomic number is 4, we need to have 4 protons, right? And also, because there's 4 protons, there needs to be 4 electrons as well. If we look at our atomic mass, we said it's 9, all right? So because we have 4 protons, how many neutrons will we have? Remember, atomic mass tells me protons plus neutrons, which is the total. So if I have 4 protons, how many neutrons do I have? Yes, I have 5 neutrons. Good, guys. Yeah, excellently. All right, so I think you guys understand that it's pretty simple. In your exams, you will be drawing atoms for me, and yeah, so yes.
Can you record, like, can you also send me the class, ma'am? Because I think, because Lesejo's not here, ma'am.
Why isn't Lesejo here?
I'm not sure, ma'am.
Okay.
Ma'am, I am here.
Oh, she's here? Ah, I didn't know.
Oh my gosh. Okay, how are you?
You, ma'am.
Do you mind showing me your face? I really want to know how you look.
Ma'am, I have a towel on my head because I just took a shower.
All right, but the next time I want you to introduce yourself, okay?
Yes, ma'am.
Okay, what school were you in before?
I was at St. Mary's DSG.
Cool. All right, so welcome aboard, Lesejo. We're going to get to know you with time.
Okay, thank you, ma'am.
Yeah.
Okay.
TikTok.
Why are you laughing, Lee?
Lee always makes us laugh.
All right.
Yeah.
Okay, guys, so next, back to the lesson. Now, the weird thing is, in class, time really seems to drag, but on Google Classroom, it's like fast. My lessons are usually not longer than 20 minutes. Okay, so now, guys, this is where the interesting part comes, right? So I want you guys to help me answer this, because I know you can, because we've just done it. I'm just deleting all of these numbers here, right? And I want those people to answer me who are very quiet in the chat now. Amy and Sibu isn't talking much today, and Gary as well.
I think you missed one, man.
Okay. All right. So please mute yourselves. We look at the atom of beryllium once again. Tell me its atomic number in the chat. What is the atomic number of beryllium? Atomic number is the smaller number. 4. Good. What is its mass number? And we need to round off to the nearest whole number. 9. Good. Number of protons. Good, Gabby. It's also 9. Am I right? Is it 9? It's actually 4, right? Sorry about that, guys. Amma says, ma'am, I have a question. Will we be doing online prepared reading? You guys will be doing unprepared reading for me this term. Okay, so not prepared reading. But if you need to do a speech or something, then you guys will be recording yourselves at home and sending me the video. Online. Yeah, most probably. If it's going to be difficult for us, then obviously we won't do it. But yeah, Kian says H. I know the feeling. Okay, number of electrons. So there's 4 protons. How many electrons are there? Yes, Amma, I can't wait to hear your beautiful voice. No, people are saying 5 electrons. Guys, that's the number of neutrons. Remember, the number of electrons are equal to the number of protons. 4. Okay, number of neutrons. Number of neutrons are protons plus something will give me 9. Right, it's 5. Does everyone know how I got to the 5 there? No. Okay, so if you want to find the number of neutrons, you look at the mass number, which is the bigger number, right? The mass number tells me the number of protons plus the number of neutrons. So we already know the number of protons is 4. So 4 plus what will give me 9, which is 5. Lastly, nucleons. Nucleons are all the stuff that inhabit the nucleus, that live in the nucleus of an atom, right? So nucleons are protons and neutrons. What are the number of nucleons, guys? Nucleons are protons plus neutrons. 9. And if you can see that nucleons and the mass number are the same thing. Good, Michael. Good, Gabby and Christopher. Okay, so we're going to keep on practicing this over and over again. And in your exam, I'm going to show you a picture of an atom, or I'm going to tell you, look for the atom in group 7, row 1, and tell me what is the atomic number, the mass number, blah, blah, blah. Right? Okay. I want you all to complete this for oxygen. Right? You can do it right now on the chat. So write down your answers for oxygen's atomic number, atomic mass number, number of protons, electrons, neutrons, and nucleons. I'll give you 3 minutes.
Man, how are people so fast? I'm still counting these things, man. Yo.
Take your time. Guys, don't write individual answers, right? Write it in one text. So like this, atomic number. Oh, okay, I see you can't write it in one text. Okay, then just write it in one go. I'll show you an example. Oh, Lee has written it in one text. It's working for him. Okay, so people are saying that the atomic number is, drumroll, 8. Mass number. Let me rather call out the question, then you guys can answer it for me, all right? Because it's a little bit chaotic here. Okay, what is the mass number, guys? Just type me the number. Good, and you guys remembered you needed to round it off. Good, guys. Okay, number of protons. Number of protons is equal to atomic number 8. Okay, number of electrons is equal to the number of protons, which is, someone wrote 4. It's not 4, it's 8. Good, guys. I'm seeing a lot of 8s. That's a very good sign. Number of neutrons. So number of neutrons is, you can find it through the mass number, right? So you take 8, which is the number of protons, plus what gives me 16. Good, Kian. 8 plus 8 gives me 16, so the number of neutrons is 8. Remember, we're rounding off oxygen's mass number from 15.9994 to 16 as the whole number. Good. Number of nucleons is equal to the mass number, so it is 16. Very good. Okay, we are nearing the end. Well done, guys. I love the engagement. I love it. Excellent. I love how you guys are all typing to me and trying. Well done. Okay, so there are 2 kinds of elements in nature, right? Remember what an element is? There are 118 known elements on the periodic table. Okay, so everything around you, everything in the galaxies is made up of maybe that element on its own or a combination of those elements. So we look at the element of, or the compound of water. Water is made out of hydrogen and oxygen. Okay, so we take the 2, we bond them together, and then we get water, right? But if we look at oxygen on its own, oxygen is just an element. It's not a compound, right? So it's a loner. So we get 2 kinds of elements. The first kind of element is an atom or an element that exists as one atom at a time, right? So who can tell me what Fe is? What's the name for the symbol Fe? Good, Christopher. Iron. So iron exists on its own, right? But if we look at other elements such as hydrogen, nitrogen, fluorine, oxygen, chlorine, and bromine, all of those exist as 2 atoms bonded together. So if you had to have like a random hydrogen atom floating in the air, it's never going to exist as 1 atom at a time. It's always going to exist as 2 atoms at a time, right? And we call those atoms diatomic molecules, right? So I'm going to repeat myself. There are 7 types of atoms on the periodic table that exist as 2 atoms bonded together. When 2 atoms are bonded together in nature, so you can't separate them, right? We call it diatomic molecules. Right. What is a molecule? A molecule is when we have 2 or more atoms bonded together, right? And I found a really cool way to memorize the 7 diatomic molecules. It's have no fear of ice cold beer, right? Have stands for hydrogen. No stands for nitrogen. Fear stands for, what does fear stand for? Tell me in the chat. Fluorine, very nice. And when do we use fluorine? What does fluorine exist in? We use it every day when we wake up in the morning. Like fluoride. Okay, so I'm going to tell you guys. Fluorine is in our toothpaste. Excellent, Christopher, right? So, and then we look at OF. OF stands for oxygen. Ice stands for, I forgot to add this element. It's actually iodine. All right. And cold stands for chlorine. Chlorine is the poisonous acid or gas. All right. And beer stands for bromine. So you're never going to forget this. Have no fear of ice cold beer. So if I ask you in your paper, what are the 7 diatomic molecules? You're not going to tell me have no fear of ice or beer, but you're going to tell me what each letter stands for. All right. Can you guys see how I've written it as? Look at the chemical formula that I've written it as. So hydrogen over there, it's an H, and there's a small 2 next to the H. The 2 is representing the diatomic molecule. 2 atoms bonded together. All right. Okay, and lastly, actually secondly, before we end, this is your homework task for today. All right, so you're going to give the name and fill in the information for the element below, right? So I'm not telling you what element this is. You're going to have to figure it out on your own. All right, so now we're going to go to something a little bit fun. Have you guys listened to the periodic table song? Who is who has been exposed to that before? Actually, a really fun song. I'm going to let you guys listen to it now, okay? Good. All right. Must we include it in our drive? Yes. So I'm going to send this to you on Google Classroom in like 2 hours or so, and then you guys will complete it for homework. Okay. All right. I'm going to play the song. If you guys can't hear it, tell me immediately.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, and lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen, so you need chlorine for your pretty tea, neon to line up the signs, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium, so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table. No gas is stable. Halogens and alkali react aggressively. Period will see you outer shell of the electrons are added moving to the right. Iron is the 26th, and cobalt, nickel, point again. Copper, zinc, and gallium, germanium, and arsenic, and bromine, and ultratron helps light up your room.
All right, guys, tell me in the chat if you could hear that and how was the connection there. I'm keeping my fingers crossed with that. I really hope that the connection was good. It was all right. Okay. Okay, so we're going to look through a few of these atoms, right? And we're going to see, I'm going to talk to you a little bit about their properties and what they're known for. Christopher says, yes, ma'am, I could. However, it fits slow sometimes for me. Okay. Ted says, wasn't the best, but yeah. All right, so we're not going to watch that much videos then online. All right. I'll stick to showing you guys pictures. So the first element of the periodic table is hydrogen. We know that hydrogen is the lightest, right? It's the smallest element, but it's also the lightest element. It's the lightest because it only has 1 proton in the middle and 1 electron on the outer orbitals, all right? What is hydrogen known for? Hydrogen is known to be basically 90% of the universe is made out of hydrogen, okay? Even more, actually. Also, it's the only element to exist without any neutrons in the middle. So it only has 1 proton and 1 electron. It has no neutrons, which is pretty interesting. Okay, then we come to the next element, which is helium. We all know helium. It's pretty cool when you breathe it in. Beryllium is interesting because I did tell you guys that metals are malleable, right? So that means that if you take a metal, you can hammer it to such an extent that it becomes flat. So if you look, you all have foil in your kitchens, right? Aluminium foil is also a metal, but it's been hammered until it is extremely thin and flexible. The same with beryllium. Beryllium is used in nuclear bombs, all right? And they use it, they hammer it down and they coat the bombs with beryllium. Carbon, we know that carbon under huge and large pressures, carbon is pressurized into diamond. Did you guys know that, I don't know what this guy's name was, but he was the first scientist to create an artificial diamond. And he done this by pressurizing carbon to such an extent where it actually became a diamond. All right, nitrogen, 78% of the atmosphere is made out of nitrogen, but unfortunately, we can't use this nitrogen for anything. It's basically useless. Okay, fluorine, we do know it's in our toothpaste. Neon. Neon is an exciting element because we use it in our neon lights. Sodium is used in salt. Magnesium is used in fireworks, all right? So anytime we burn magnesium, it gives us really, really bright white light, which is awesome for fireworks. The next one is aluminium, but I feel like I'm missing one in the middle here. Okay, silicone. Silicone is used whenever you go for plastic surgery, all right? So just say you want new boobs or you want whatever else you want, right? Then they inject silicone into your body. All right. Potassium is in bananas. We need potassium in order to for our muscles and bones to function well. Calcium is also in our bones. These are all metals, right, guys? But they don't look like metals in our bodies because they are combined with other elements that mask that metal effect. Okay, manganese is used in batteries. And that is the end of our lesson. I hope you guys enjoyed it. I will be sending the homework onto Google Classroom. And please, please, check out Google Drive, explore it, right?